Okay, so is this video 174? 174, it is Thursday. Okay. Basic UI, technically we're not going to do this thing called TAUFRAG. And it's going to be the fragment shader code for the Tau Depot system, right? So I'm just going to put this in a nice little label right here. Center that. Yeah, it's all very technical. There we go. Okay, yeah, this is what we're going to work on. And I did some code at the machine shop, so we're going to sync up our Git repo with that. Is scenes. Okay. Keep tech demo day. It's probably good to remind me of what's going on. Not all these scenes have sound. I better fix. Okay, now I got sound here. Remove. We're just going to remove some scenes and do some cleanup here. Agenda screen, you stay. Agenda screen is very useful. Break screen stays, but now I actually have some volume. Okay. And okay, this screen also stays because I use this all the time. This stays. This has been used. Okay, this I'm going to keep as well. This I'm going to keep as well. I'm turning on the sound for all these things. Sounds here, sound, sound, sound. Any of these don't have sound. Okay, so we've cleaned up our scenes. We've cleaned up our scenes, and we've given what do you call it? We've cleaned up some of our scenes. We've made sure all of them have sound. And I like this agenda screen, but I also want to make another agenda screen. So I'm going to rename this agenda screen. It's going to be called, like, I'm going to make another agenda screen. So I'll be... This is going to black out the screen really quick, but... Okay, so we're just going to make a quick little agenda screen for today. So one, to okay, so we got like 3 things we want to do. I want to just do these today. So these are things that I want to do today. And I have another list of things I want to do that are like more overarching or project specific, but this is kind of what I want to do today. Okay. So let's open up our dashboard and see if we can, because I haven't been looking at chat, so I should probably look at that. Let's turn our shortcuts back on. And then I'll check. Because I am bad with this. Oh, God. Okay, anyways, bitrate's horrible. That sucks, as usual. Let's actually go move this down here for a second. Actually, no, let's not move that down. If we're looking at whispers, we probably shouldn't put that on the public screen, because you never know. Oh. I got sidetracked by, shit. But anyways, fuck. I got distracted. Okay, anyways, what am I doing here? Well, what's our time here? 13, 14 minutes? Okay, so we haven't been distracted for too long. Okay, so we want to go into here. We want to commit the changes that we made at the shop. So... Okay, so we made some changes at MakerWorks. While we're at MakerWorks and cutting parts, we made some code changes. And we want to push those back up to... Oops. We want to go push those back up to the main kind of thing. And then we're going to pull them back down. Okay. So now we'll go pull them back down. Why does it say F drive? Oh yeah, no, okay. We're gonna go pull down to our main R drive. And blah, I'm not focused here. Oh yeah, I can show you what I'm up to. I'll give you crap. Do I have a? I have some tech demos I can show you. Oh yeah, let me show you. So let me get my demos open and I will explain. And I will okay. It's like I don't even feel like it's... I don't even want to talk right now because my bitrate just sucks, so I don't know if you can hear me. I'm just gonna... Yeah, I may have said I may have said something and then I Yeah, so... Yeah, so... I'm gonna get to it. This is probably gonna be boring. But it was good talking to you, but yeah, this is just gonna be boring kind of stuff. Because I'm like in the middle of... I'm in the middle of a whole bunch of stuff. And... it's like, let's see. I'm in the middle of a whole bunch of stuff, and it's already confusing enough what I'm in the middle of, and if the stream's just gonna break up, it's not gonna be really useful. Get fetch. I don't believe it. But yeah. Okay, anyways, let's pull those changes we made at the shop. And then let's stub in the yeah, let's okay, so we got that stubbed in. And let's get to it. Let's go in our library. Let's go find the system that we're editing right now. And we actually want to open up like all these. All these are kind of like of interest to us at the moment. And let's just put these over here on... let's just split screen this. Put this over here. Let's put this over here. Let's get all nice and set up. Let's, I don't know, put that over there. Put this over here. Yeah, I'm hoping to add that feature, the radial mirroring that you're seeing. I'm hoping to add that into the game engine that I'm working on. But it's going to be a while. It's going to be a while. But I am hoping on doing that. But it's going to take time. Like, everything I'm doing is going to take time. Because it's C code. It's like, C code takes forever to write. And I knew that when I got into it. Okay, so I got yeah. Uh, oh, shit. Yeah, the best engine is nothing without skilled art. You gotta have some. You gotta have an artist who knows what they're doing. When you have an engine, right? Because right, all engines are the same without art, right? They're just a black screen. Okay, so we need to get this subsystem in. We have a little about section here. We have a unit test section. We need to just paste the usual functions that we kind of use for every single system. Kind of some boilerplate code. So let's just say paste AAC 2020 boilerplate and just see where that gets us, right? See if that shortcut is a thing. And it is a thing, but it says that I should be using this nsbp paste. So this is the boilerplate for a typical system in my library, and you'll notice that these asterisks are for the name of the system, right? So this particular system is called TAUFRAG. So we're going to go where every part you see that's highlighted in orange. We're just going to do like quick, simple find and replace, and then some things need to be uppercase, so this should be uppercase, and then that should be lowercase, and this should be uppercase. So in C code you don't have any namespaces. Oh hey, look, my bitrate is a little bit better. Yes, awesome. In C you don't in C you don't have namespaces. So if we want to avoid collisions with variables, we have to be kind of verbose, and it's kind of annoying. But the nice thing is that when you look at a variable or a function, you always know where it's coming from, right? Like I automatically know, oh yeah, this function here is in this project, and it's this subsystem, and the function name is this, right? So I know like exactly where my code is, right? Like connecting the dots is the hardest part. Oh, cool deal. So yeah, connecting those dots is pretty much the hardest part. So anyways, now that we've kind of stubbed in this system, there's some other kind of nonsense I have to do to get this working. So this SIL is a macro for this silence system, and the silence system is used to control what logging messages are turned on and off for different systems. So we got to go find that. And inside this system, we just have a big list of all of the different subsystems in the game, or in the game engine, I guess you could say. And we want to add this one, but we want to add it in the correct position. So if we look at our main C file, and we look at the order at which we're going to put all these systems in, it looks like I've decided that TAUFRAG is going to come right after TAUSync, right? So if we look in here, here's kind of like my Tau systems here. So we're just going to duplicate this, and then we're just going to rename this to TAUFRAG, right? So the fragment shader code. And then we're going to go down here as well, and we're going to find TAUSync again. We're going to duplicate that, and TAUFRAG, right? Now, since this is a new system, we want to automatically turn logging on for any new systems, right? Once the system has stabilized and we're like satisfied with it, we're just going to turn it off, right? But for any systems that we're not quite done with, or we're still interested in looking at, we'll keep the logging on. And then if a certain system just starts to annoy the heck out of us, or if we're done working on it, then we'll flag it as off. As a kid, I wanted to be a designer and learn to do HTML websites by myself, but I already forgot everything. Then in university, I learned brackets or some shit. Oh, cool. Oh yeah, I mean, I know you can forget stuff, like... Yep. Let me think. 16? So, like... Yeah. No, I get it. Like, it's so easy to forget stuff. Like, okay, well, my bitrate's working, so I can actually just tell you directly rather than type it out. But okay, so I did like years worth of Java code. Like, you know, I wrote Java code for like 2 years, right? And then, you know, 5 years passed. I haven't written any Java code because I hate Java, right? So I go into this interview expecting only to get tested on JavaScript, right? And like I do pretty good on the JavaScript. On the JavaScript test, like I have to like write code in front of the interviewer, right? And then I get thrown some Java, and I'm like, oh crap, I haven't written any Java in 5 years. I used to write Java all the time. I can't even write like one line of Java. It's like, oh god, how do you declare a variable in Java again? Like, I don't remember. And then they're like, what the heck? You said on your resume that you knew Java, right? Yeah, cool. All right, cool. But yeah, it sucked. And then I will say that if you want to get a job somewhere doing code, I have no clue what your aspirations are, but this is just kind of related. So I totally bombed that interview, right? I bombed it horribly. And so what I did was I'm like, well, you know what? I already got the manager's email. So here's what I'm going to do. Every month, I'm going to message this person, and I'm going to be like, here's the stuff I'm working on related to Java, right? And so I made like a database-driven application in Java, and I showed it to them, and then I got hired. And the job sucked. And I was only there for like 4 months, but it was like $65K a year salary. So I mean, it was good pay, but holy crap, my boss, not easy to work with. Like gives you anxiety, like, cause he would like, you'd have a talk with him, right? And then you'd have a talk with him over the phone. And then if you didn't, like, add more code to the code base in under, like, 15 minutes, like, he would be calling you again being like, hey, what's up? Why don't I see any, like, work going through here? Blah, blah, blah. And it's like, Jesus Christ. Like, I like deadlines. A deadline that's, like, get this done by the end of the day is great. But, like, a deadline where it's like, hey, get this done in the next 5 minutes, the next 10 minutes. Holy crap, I cannot handle that kind of stuff, and I was getting thrown that kind of stuff. But yeah, yeah, it's, code is hard, man. I mean, at least I don't have to, like, punch little numbers and things into, like, little punch cards like old school programmers had to do. Like, holy crap, I don't even know how they did that. But yeah, anyways, my code is not a, my code is crazy. My code is batshit crazy. So, watching this stream can give you a really bad, what do you call it? So, watching anything I do can give people the wrong impression on what is normal, because what I do, I never do anything normal. Like, to give a real-life example of not normal, in college, I had a German roommate. Yeah. Oh, thanks, yeah. So in college, I had, like, a German roommate, right? And, like, I told him when I met him that, you know, oh, don't take me as an example of what, like, American people are like, because you're gonna get this shit totally wrong. Because, like, first of all, I went out by the railroad tracks in Redmond, Washington, you know, like, where, like, Microsoft is, and I built a zip line on a tractor tire in the middle of Redmond, Washington. And it was up there for 2 years before any kind of, like, authorities were able to find it. Now, if the police come find me, I'm totally making this up. That's totally not true. But there is a video on the internet. If you want to take a look at it, I'll send it to you. But, like, you know, I did crazy stuff. And I'm still doing crazy stuff. So, what you see here is all of these systems included in my project in a very linear order. So you might be familiar with, like, dependency injection, or a dependency graph, or like when a project has certain dependencies, those dependencies have to be added to the executable in a very specific order. And so when you have a graph of dependencies, that tree of dependencies eventually has to be solved and turned into a linear list of dependencies. So what I did here is I solved that list myself, which is kind of crazy stuff. But the reason I solved it myself like this, these dependencies actually conceptually do correspond to some type of graph. Like, I do have some diagrams for what that actually looks like. So if we go into the README, I've made the attempt at making some crappy ASCII diagrams for specifically this, so if we can find the diagrams for that. Right, so I have some ideas where, like, okay, the silence, the kill test, the re-entrant unit test runner, the to-do manager, those are all the top-level dependencies. And then we have a game ticker, like the game time. So this is responsible for game time. This is responsible for keeping track of the current editor. And then we have a thing called file boy, which is for file access. And then we have this PNG hex dumper that needs to use file boy. We have a native dialog user interfaces that also uses the file boy. Then we have this thing called hard-ass, which is for hard-coded assets, which needs to use the PNG hex dumper, and the PNG hex dumper needs to use this, right? So then we have some other diagrams of, like, okay, the native keyboard and the native mouse, we don't care what order those are included in, but then the iKey box and the iMouse box, those are grouped together and they reference these, right? So the order here doesn't matter and the order here doesn't matter, but all of these need to come before all of these, right? And then keybind is going to reference this stuff, right? And then these three things are kind of grouped together, right? And so, like, I have this crazy diagrams of, like, how everything's supposed to be pumped into the system. So right here we have this thing called pixname, which is just, it stands for pixel name. It's just the name of certain memory allocations. So I'm trying to store all my memory as pixels, which is really weird to do. And I could explain why I'm doing that once I get the code compiling, but unfortunately it's broken right now. Okay. Okay, let's just get this thing running. So we want TAUFRAG to be in here. UIRX, this needs to be put somewhere, but I don't think it's gonna go. I don't know where this is gonna go yet. Let's move this out of here. And let's start getting this in here. So let's just copy this for a second. And let's call this TAUFRAG, right? And we need to shift up all these numbers. So, right, so TAUFRAG is right here. So we got TAUSync, and then we have this, and then in the middle we have TAUFRAG, right? So we need to take these numbers and we need to shift them up. So I'm just going to take these numbers and shift them up like that. And now we have 51 systems total, okay? So down here, we have the 51 systems, so I want to compile up to the 51st system, so basically I want to compile the entire project. So these have different numbers. Okay, so we're gonna change. We have to change the build system to support this. So this is kind of a summary of all the systems, but we actually have to open up the code that's responsible for this. So if we look at libchan, so it's libchan top and bottom files. Let's go put these over. Let's close these for a second. So libchan top and libchan bot are kind of like my build system files. Yeah, so right up here I can see that it's red. Okay, we got some blue again. I'm just gonna keep track of when it's blue, and if the stream is blue, I'll talk. If it's not, I'll just type. So this thing called libchan is kind of like the master file for my build system. And so a lot of times people writing C code will use a thing called a make file or a thing called cmake. And well, makefile I believe is C++, and then cmake is for C. I don't know exactly how it works because I like to write my code in a very rudimentary way. Like, I know my code might look really complicated, but I also like simplicity. So I'm like the person who, when I lived alone, I just had like a pocket knife, a plate, a bowl, and like one pot, one pan, right? And the idea was that, you know, I can do a lot with a pocket knife, and a pocket knife is better than having like a blender and some other food processor and then a waffle iron, like all those different tools in a kitchen, right? You can have so many specialized tools that, oh, they're super useful and efficient, but then they start to clutter up your life. I kind of see the same thing with code sometimes, where there's like all these fancy tools you can use, but I don't think they're free. I think they come at a cost of like a complicating your life. So I already write code that's complicated enough, so I try to keep my build system really simple, even though it may not look that way. And so what do I mean by simple? Well, I don't use like any external tools really. I have all my source files, then I have like a bash script that runs like a few compiler commands, and that's my build system. I don't have any fancy IDE. I don't have any make files. It's just really simple rudimentary stuff. And that's because if I'm going to make a very large okay, anyways, let's get this in here. So we have 51 different systems. So we're gonna add this number here, and these are just defines right there. They're literally just defines for individual numbers 1, 2, 3, 4. Right. The number here matches the number here, and that is will be more obvious as to why that's used in the code, right? But once again, dead simple things right here. So there's like a lot of code right here, but the pattern is very obvious, right? The reason why I'm going to write a lot of code where there's a very obvious pattern in the code. Okay, so okay, so we got these things here. We can make sure that the numbers match really quick, right? So if we're really paranoid, we can do some token highlighting just to make sure that that all matches up. And we see that the last number matches this max, so that's good. And let's go through these systems. We want to go find number 43. So way down here. Okay, so 42 and 43. So 43 is tau sync, right? So we got tau sync. And then we have zoom common code. So zoom common code. So between here and here is where I want to make an insertion. So what we're going to do is we're going to just steal this for a second. We're going to steal this. We're going to paste this. And we're going to replace this with TAUFRAG, right? This is the new system I want to insert into my build. And we have to renumber some of this stuff, which just sucks, but that's what we're going to have to do. Also, the system here kind of breaks some of the patterns that are in my code. So if we look at TAUFRAG, it has these other files. So I also need to include this file. So we're going to call it... so I need to include this as well. And whenever I include something a little bit different like this, what we're going to do here is I'm going to say hashtag pattern breaker, right? So I try to keep my code very uniform, but every once in a while, code is very much like natural language. You know, like with English, right? You have rules in English, but you always have those rules that are broken. Same thing with my code base, right? We have these rules, right? We have this very obvious pattern here, but every once in a while, for whatever reason, you need to break some rules, right? So pattern breaker is just a little hashtag. This is just a little hashtag right here to let me know, hey, this right here is breaking some type of pattern, right? And I also have another pattern breaker I need to address. And actually, this doesn't go here. This goes in the functions section, I believe. Or does it go here? Let me think about that. Yeah, I guess it really belongs more in the functions section. So I'm gonna put this over here in case I forget about that. But let's renumber this. I would have done an infographic for myself. ELAC, design, and iProgramming. Yeah, yeah. So, yeah, yeah. Anyways, let's change some of these numbers here. So, if we look at our list here, TAUFRAG is going to be system number 44, right? So we're going to just change these numbers to 44 right here, and then all these numbers have to be pumped up to the next number. And this kind of sucks. Like this part of how I'm assembling everything together, it absolutely sucks. The trade-off here is this is a very inflexible, hard to edit design that I've put together, but the trade-off is that there's a lack of abstraction, and with a lack of abstraction, there's more clarity, right? So the less abstract you are, the easier you are to understand, But if you are less abstract, you are also less flexible. Okay, let's go down here. Okay, so in here, let's copy this. Also, I'll okay, so let's change these numbers here. So this is, this should be 44 now. So let's go change this to 44. And then we'll also think about where to put the, put those top and bottom files. So, okay. So that looks good. And then the next thing I want to do here is I made a note of this, right? That I want to take this pattern breaker and I want to put it in here because technically this is fragment shader code and it's the top file for the fragment shader code. So I think it more so belongs here. Now I could be wrong here. I don't know. Well, technically it's more data than it is functions. So, God, I don't know. Oh, also, this name is wrong. What the heck am I doing here? Okay, so that's the new name I want. It would be good to color these differently for a second. So what I'm doing here is called token highlighting. And it's just so that I can... instead of using syntax highlighting, I just highlight things the color that I want so I know what to focus on. Okay, so let's go take a look around here. So we're here, and then over here in the data section. I really don't know. Well, if we look at bottom, if we look at this file here, it's just defines. It's all defines, right? So technically this is all data. It's not, like, I want to keep my data and my functions grouped together. So I'd say this looks more like data. So in here, I'm going to say that, that this goes here, right? I think that makes sense. Fragment shader is just data. Do you want to keep it that way, or are we going to have to end up... let's just keep it that way for now. Let's make a note of where we are. Okay, so, yeah, we'll put that there. And... So, so this file is called a top file, and it's a file that needs to be included at the beginning of the project. Like, the code I include a file called the top file. I include a whole bunch of code and make some changes, and then eventually I want to undo all those changes. And when I want to undo those changes, I use the bottom file, right? So, dot bot equals dot bottom. Okay, and that looks good there. Okay, so let's go look for tau sync here. So we got these two things here, right? And we want to make an entry in the middle, right? So we're going to steal this. We're going to paste that there. And then this right here, we're going to replace as TAUFRAG. Okay, TAUFRAG. And that part looks good. That's good. Then what do we got here? One more redundant check before we undefine. So let's look at this. Right here. Okay, we got this right here. So we're going to make another insertion here. Okay. Paste that in there. And then this right here is going to be called TAUFRAG. And then this number needs to be changed, right? So what we're going to do is we're going to drag these numbers up. So we're going to go here. And then just here like that. Paste that there. And change this to 51. And that's good enough. I'm not going to worry about these little dashes. Okay. So down here, same deal, right? So we're going to duplicate this. We're going to rename this to TAUFRAG. And then we're going to move everything up. So what I'm doing here is these are undefs. And an undef, you could think of an undef as deleting a variable, right? So define, you could think of creating a variable, and then you could think of an undef as deleting a variable. Or if you want to think of it even more correctly, you could think of a define as creating a constant variable, and then an undef is deleting that constant variable. However, defines and undefines, they're not actually variables. They're literal pieces of text in the code, right? So most of the time you can think of defines as like constant variables, and that'll usually be a good enough abstraction to understand code that is using defines. But eventually, once you get advanced enough into C code, you're really going to need to understand that that defines are literal text. So when we look at this define macro whatever, and it's set to 46, the value for this variable here is open paren 46 space close paren. That is its value, right? Its value is that. Its value is not 46, its value is this whole thing here. And that's important because what happens when you compile C code is there is a step called the pre-processing step. And the preprocessor goes through all of your source code and it does a find and replace. So it'll look for this token here and it'll replace it with this, right? So anywhere it sees this, it will cut and paste this into your source code. And then after it's done that pre-processing find and replace kind of nonsense, then it will actually compile the code. So defines and undefines are for kind of managing the preprocessor and managing the cutting and pasting of text tokens. So it can be a little bit hard to wrap your mind around, but I have a good video that I kind of explained it before, but there's plenty of good explanations on the internet as well. Okay, so we got this in here, and what else do we need to do here? Because we're like all over the place. Okay, we also have to open up F macros. So yeah, there's just a lot of rigidity and things that I wish I didn't have to do when I add a new system into my code base, but this is just the way it is, so oh well. So we're gonna go look for TAUSync and go find that. So it's like 43. So these numbers may have changed. TAUSync is 43, but then PAINT5D is probably now 50, right? So this needs to be changed. And a lot of these things might look very, very frail, where it's like, oh god, I gotta make sure that these numbers are exactly this. But it's actually just redundancy, right? So there's a lot of redundancy where this file's values have to agree with this file's values, and a whole bunch of other files, their values all have to agree. And it's just a way to make sure that I don't make any mistakes. So that if I make a single mistake in the code base somewhere, the code will refuse to compile, and I'll be able to figure out why that is. So it's just redundancy to help me make sure that I don't make mistakes. Okay, so if we look at this, this is init none functions. Do I need an init none, or do I need something more intense? Now, I'd say an init none is probably fine for this TAUFRAG system. So we're going to go look for maybe TAUSync if it's in here. And we're just going to make an entry called TAUFRAG, right? So TAUFRAG, so we got TAUSync, we got the Zoom common code, and then we have TAUFRAG, right? And so now we're going to go, rather than regenerate this whole list procedurally, I think it's going to be faster just to scroll down in here and find this block of code, right? And a lot of this I could do with some type of auto-generating system, and I'm getting to the point where I probably should do it, but for now, this is what I have. And yeah, so we'll just take this and do a quick find and replace, and we'll just TAUFRAG. We'll just replace it with this, because it's not too much to just add it in like this, rather than procedurally rebuild all these little stubs. I think that is quick enough just to do this, right? Bam, it's in there. Okay. So that looks good. I'm not going to update this list just because I'm sick of updating this list. And I also have a note that says not guaranteed to be up to date, so I'm going to roll with that guarantee and say it's not up to date. So F macros, bottom file. Okay, so in here, we're going to clean up after ourselves so that if someone else is using our engine code, they don't have like this plethora of a whole bunch of different variables and things being added to their preprocessor, because that would be that wouldn't be very nice. So what we're going to do is once again, we're going to go find TAUSync, right, and Zoom common. And then in here, in the middle of here, right, we're just going to say this needs to be called TAUFRAG. Okay? And then we're just going to take this, paste that, make that 51. And TAUFRAG, is that an init none function for TAUFRAG? Yes, it is, because we decided we don't really need any fancy initialization code. Okay. So you might wonder, like, why do I have init none and then init functions? The idea is that if you've ever heard in elementary school, or like elementary school, middle school, you might have had a teacher that made like a stupid joke where they're like, raise your hand if you're not here, right? Well, how can you raise your hand if you're not here? Well, you can't do that in real life, but you can do that in code, right? So some of the systems need to be initialized, and then other systems don't need to be initialized. So rather than just omit this, right, I say, okay, this system needs to be explicitly initialized, and then this system here explicitly does not initialize. So this is basically like saying, hey, raise your hand if you're not here. So it's like a way to, so this is kind of like, this initialization list here is basically like a way to take roll call of all my systems. And if a system does not have any initialization code, I can still kind of include it in this roll call by giving it an init none function. So I think it's very important to tell people why you did what you did, but it's also very important to tell people why you didn't do what you didn't do. And that can be a little bit trickier to add into code. So, but I have done it through this, right? And it is a little bit awkward, but that's the reason for that. Okay. So we got F macros, that. We got the bottom file. Actually, let's go look at, yeah, the bottom file, that's fine. That's fine. Okay, so one other thing we got to do is we got to open up our main file, like our main entry point. So this is our main entry point code. This is our top level code. And it's just called F for functions, right? Top level functions. And in here, we have the actual calls to the different initializers. And unfortunately, the initializers are broken up into two sections. Initializers that happen before the window exists, and then initializers that happen after the window exists. In a perfect world, I would put all of my initializers into one section. But the reality of how the code needs to work with native window code, the reality of the code got in the way of my perfect design, right? And sometimes that sucks. Reality gets in the way and screws you over. So anyways, we're going to add this. So we have tau sync here. We have zoom.com here, right? So all we got to do, duplicate this line here. And we're going to call this one right here, we're going to call TAUFRAG, right? And then we're going to shift these numbers up. And I'm a little bit worried here because I don't think that's 49. Yeah, where did we screw up here? So it looks to me like at some point in time, why is our checksum not correct? So see, I already can tell there's a mistake because this is 49, this says 51. I'm not a happy camper. So we're going to have to look over our code and see, well, where did the numbers go wrong? So let's just spot check here. Okay, 27. Is 27 correct? No, it's not, because it's GPU data, but it should be like pixsave. Okay. So we're going to have to painstakingly look at this one thing at a time, I guess. So Gina Mao. And is this, well, here's Gina Win, which would be the window code, and then native dialog user interface would be 19. Okay, so this should be a 19, which means if we're lucky, we just gotta shift this up, right? So if we're lucky, all that has happened is that this code, these numbers just need to be shifted up, and we might be a good standing here. So if we make this 19, and then we make this 50, and we make this 51, then it looks like that checks out. So 43, 44, and 45 for these. 43, 44, and 45. Let's spot check 29 and 30 here. Is 29 GPU data? Yeah, GPU data, pix push, and pix load. Yeah, so that's good here. Okay, so we got this in place, and you notice that it says do not extract, control F help. So these are the actual functions we want to call. But these functions may or may not exist depending on how far we've compiled this library chain, right? So if we compile all the way up to system number 51, with this variable. This variable says compile up to number 51, and so it means take all these things and compile them, right? Now, but if we only compile up to 36, right, then fragcom function wouldn't exist, right? So if you look at fragcom is right here. So if we tried to call this and we didn't compile this, then we're going to have a problem, right? So rather than call this directly, rather than call this fragcom init none function directly, right, with this AAC 2020 fragcom init none, we use this thing called f macros, right? So this is f macros, whereas this prefix here is the actual code base, right? So this is like these wrapper functions, if the code actually exists, will create functions when we pre-process the code. And if these functions don't exist when we pre-process the code, these lines will just be converted to blank lines of code. So it's just a way to make the code a little bit more streamlined so that I don't have to wrap all of these function calls in preprocessor conditionals. Okay, so right here we know that we need to insert within here. We need to insert TAUFRAG, right? And it's an init none function, so that's fine. And if we did everything correctly, we can take this exact checksum here, and we can just paste it right here to update this checksum. And that looks good. Okay, cool. So we got these calls here. That looks good. The next thing is, do those init none functions actually exist? Because I don't honestly know. So let's close some of this stuff, and let's look at the TAUFRAG system. So let's go open up TAUFRAG, and here is the function file. And if we look at this, we should have an init none in here, I believe. Yeah, here's an init none. But we need to edit this a little bit, because even though it's an init none function, what we're going to do is we're going to just, unless the unit tests are very heavyweight, we're going to call the unit test code from within here, right? And so we're just going to say, we're just going to call it with the 0. We don't really care what it is. And then because the function appears lower down, we have to do a forward declaration. So this is going to be a forward declaration here. Anytime you see a forward declaration before anytime you see a forward declaration before a function call, it means that the function is declared lower down in the file. And if you do not see a forward declaration, that means that the function that is being called exists further up in the file. So that way, when we're looking at the code, we always know which direction to scroll up or down to find the function that has been called. So, okay, that looks good there. Yeah, that'll work, I believe. So this is just a function prototype. Here's the function call, and then here is the implementation of that function, and this is just a unit test function. Okay, so. Okay, begin, and then this should be called end, right? So just a little logging message so I know when I have entered and exited the function. And then right here, we need to create a unit test section in our code. So let's create a unit test section in our code base, right? Let's just say, call it unit test section. That's good enough for me. And we're just going to kind of like encompass all of this code into like a little section thingy-mabobber that tells us kind of like what we're doing, right? Also, I should probably check my whispers because I may have had somebody else respond to me. Alright. At least they liked that comment. Because sometimes I just like sometimes I randomly whisper to people, and I'm like, one of these days I'm gonna randomly whisper to the wrong person. I'm gonna like piss them off. But anyways, yeah. So right over here we got this kind of unit test section, and we don't even know if this code is gonna work yet. I'm sure there's some things we're gonna have to fix up eventually, but we need to define U32 here. We need to define int32. We probably need to define log. I don't know if I have a thing for this. No, I don't. So define log as, you know, AAC 2020 TAUFRAG info any. So let's just make, then we also want an error message to define. So we want to define error as AAC 2020 TAUFRAG halt. So these are just, these are shorthand for these, right? So it's just a way to make my code a little bit more terse. 2, 3, 4. Okay. So now we're going to go down to the bottom here, and we're going to just undef all of this stuff, right? So all these kind of shorthand terse macros that we've made, we're going to get rid of them so that we don't pollute other files with this nonsense. Okay, so that's good. Now all this code I wrote, I don't even know if it works yet because I haven't ran it. Fingers crossed that I know what I'm doing. Num_tau, num_sub, right? There's one group here. That's why we have ×2, because I'm counting in terms of groups. There are 2 groups here, 1, 2. So num_sub should be 2, and then ×2 because there's 2 things in each group, right? Because they're pairs. The number of variables we counted to 0 to 11. So 0 to 11 is 12. We look at this. There's 12. Excellent. So that looks all pretty good. So I'm satisfied with that. And so we got this unit test function. It's being called within the init none. That all looks good. I think we're ready to try to compile and see what's about to explode in our face. So, and then once I get this done, I'm gonna, if I look at my list, for today, I want to get TAUFRAG working, then I want to work on some black market memes, and then just chatting while lurking in other streams. So I'm going to do that, because I think that, so right now, most of my viewers are from, yeah, so, yeah, I mean, right now, what I'm trying to do is, I'm trying to take some time to, like, wander around on Twitch every once in a while, and make some friends, find other like-minded people. Because right now, like, C-coders on Twitch are kind of, like, rare, I think, and so we all kind of stick together. But since all my viewers are basically just viewers from one specific channel, that channel being this person specifically, so this person specifically is kind of like where all of my fans come from, and he works on a user interface in C code for game engine stuff, and then there's another guy who does C code, and he works on an engine called the Keck engine, and he gets up ungodly early. So Dawn gets up at like 5, and then later Hirosa, he's like up at like 8 or 9, and then I don't get up early. So at least it kind of works out where we're all on this kind of like waterfall together schedule where we all kind of like do our thing in different time slots, which is kind of cool. Anyways, what the heck am I doing? Let's try to get this running. So we're going to double click our build script. Then it's going to crash on us, and we're going to figure out what kind of mistake we made, and then we're going to fix it. Why can I be so certain that that's what's going to happen? Because I know I'm not a genius, and I know that I will always screw something up, so let's figure out what we screwed up and then fix it. So Tau015 redefined. Ooh boy, that's scary. Okay, so let's go find this, and in TauDirt, so TauDirt.f defined it. And I'm gonna hope that that's just like I defined it and then forgot to like undefine it, right? That would be the best case scenario. Define Tau015, yeah, that should be undefined somewhere, and it looks like maybe we're not. Undef Tau015. Oh, I see. It's already been defined because... Oh, I see. Okay, cool. I see what's going on here. Okay. How do we want to fix that? That could be a problem. Okay, I gotta take a break. I'll be back. All right. Let's get our socks on. Let's fix this problem. Okay, so what did we mess up here? Wow, 20 minutes? I needed exactly 20 minutes, huh? I took a shower. Good to know that I know how long things take. But then work expands to fill the time allocated. Probably the same thing with a shower. Okay, so we gotta rethink what the heck we're doing here. So this top file, we're not gonna do this. We're gonna rename this. We're going to rename this to just .fragment ._, and we're not gonna have a top and bottom file. Everything is going to just need to be nicely contained within oh, I see why I did that. See why I did it, but yeah, we're not going to do it that way. Okay, so define blah 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 this stuff, define shorthand macros, right? So so these are just shorthand macros is what they are, right? They're shorthand macros, and it doesn't matter if it's C99 or OpenGL. They all get included, right? Now these are these right here are going to be like global macros, right? That's why they're longer. And then we're going to go find TAUFRAG bottom file. We're going to take all this stuff and we're going to put it in here. Right, and this is going to be the cleanup section, right? So we want to clean up. Okay, so so the actual functions that we want to use are going to go in this section here. So within the middle here is where the actual kind of like main functions go, right? So this is where it all happens. Here's where all the magic happens. Right in this section, right here. Right. So maybe you want to make that orange or something, make it a little bit more noticeable. I don't know. Right, just make it a little bit more obnoxious, but this is where we're going to put the code. And I changed my mind on the way we decided to do this. So if we try to run this again, it's going to say, oh no, some files don't exist, blah, 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 and then we'll fix that. But I just want to double-click this and make sure that I get the compiler error that I think I'm going to get, and then I'm going to fix this up. So, no such file or directory, top file, yeah. So we're going to take this bottom file, we're going to delete this. So open containing whatever the heck in Explorer. And this bottom file, we're just going to delete this. So this bottom file, we're going to delete this. Yes. Then we're going to go into libchan bottom, right? We're going to go this. We're going to open that for a second because we were putting this in here. And so don't do this unless... Okay, so you know what? We're not gonna do this unless there's no other way, right? So unless there's no other way, we're not gonna use these bottom type files, right? Okay. So now that we've gotten that taken care of, the next thing is in our libchan. So if we go look at libchan for a second, and we can close this. This data file, your data is here. That is a lie. It's just in the fragment file now, right? So we can change that. Cool. Let's close this, and then in libchan top, we had a problem where we're like, I don't know exactly where this goes, and we put it below fragcom. That's going to have to change as well. But TAUFRAG right here. TAUFRAG. Here's our pattern breaker. First of all, it's not going to be this. It's just going to be fragment. And now it's definitely function code as far as I'm concerned. There's no functions written in it yet, but it's pretty much function code. So we're going to change that around, and we're going to go down into this section here with the functions, right? It looks exactly the same. And that pattern breaker is original. Okay. And this is... Are we still on video 174? I hope we are. 174, yeah. So 174, the time is 2 hours and 5 minutes. And let's just call it 2 hours and 6 minutes by the time we get here. Move to func section. Right, so it's been moved to the function section. taufrag.fra, whatever, right? It's a pattern breaker. Okay. So that should be enough to get this compiling. And then once we get it compiling, we would like to create some common functions. Conflicting types for taufrag unit test. So let's go look at taufrag unit test. I'm going to guess that it did not like the way I did this. So if we look at this, extern void, this says U32. Now, is it supposed to be a U32, or is it just supposed to be extern, right? I don't honestly know. If you go look at some other unit tests for a second, right? So let's go look at, let's keep something consistent with the other way you write unit tests, right? So extern U32, not extern void. So it seems like we do, yeah, okay, sure, why not? So I just want to be consistent. So a U32 init none. This takes a U32, but it also is going to return a U32. So extern U32, right? Unit test, and then here's our unit test that returns a U32, and then at the very end of here, we're just going to say, you know, return 0x0, because we're not actually going to do anything with it. Okay. So let's get this compiling, and then what do we want to do? Well, we need a macro for extern void if, you know, we're going to do that. And EV there. Yeah, sure, why not? So just define EV extern void, right? And then in the unit test section, we're going to go down here, and we're going to undef EV as extern void. And then let's give that a... Okay, we gotta, let's just open up a console here, because it's getting annoying. Git bash here, open up a console, and then, okay, This is not really what I meant to do. Force of habit is to automatically commit things when I open up a console, but call that a safety save, if you will. I just want to run the build script and see if we can get this compiling. Once we get it compiling, we still have to refactor things around. Parameter names without types in function declaration, EV. So this thing here, I have no clue why that's wrong. Extern void. Well, first of all, this is not extern void. Oh, because this is v. Can just make that void. That's fine. We need to make those signatures match. I think that's, or those prototypes. We need to make the prototypes match. Unexpected for dex met. Okay, so now we're getting into the actual meat of the code we wrote while we were at the shop. And so dex met for I forget our, oh my god, did I do that everywhere? Probably because it was cut and paste code, so I guarantee the mistake is in multiple places. Now, you might say, well, what's the point of making cut and paste code? Because, oh my god, you made a mistake and you had to correct it 3 times instead of 1. Was that really that much work to correct it 3 times? And the benefit of the redundancy, and the benefit of the redundancy and repetitiveness of this code, it just makes things a lot easier to understand what the heck's going on. So, comparison between signed and unsigned integer. So, these indexes are index accessors, so they can stay that way. Dex tau depot and whatever, that's fine. Okay, so I see dex tau. Okay, that's fine. So all we're going to do here is just say, we're just going to cast those to unsigned integer, and that'll be fine. And then we'll do that everywhere else as well, right? So anywhere we're comparing these indexes, they're uint32s. The macros that these values are derived from are uint32s. Because the macro values would be kind of, they're one-dimensional index positions within a bitmap. There's no reason for them to ever be negative, because negative doesn't really apply in the scenario that we're using them for. So let's make that there, and then let's put this over here, close that off, fix our alignment. Okay, so let's give that a shot and see if we can fix this, right? We just want to get this compiling. And then we might want to, yes, tau015. So wherever we included this tau015, we need to undo that. Really? Okay, well, let's go look for this in the fragment file. So it's saying that tau015 so at some point we have screwed something up royally, and I have no clue where that is. It looks to me that it's not this. It's not this here. It's that when it got expanded into PAINT5D. So this isn't being cleaned up. So if we look at this, where this is being called tau015, we want to do some stuff with it, and then these actually need to be undefs. So this section needs to be an undef section. And that's what I intended it to be, but then I never made them undefs. So this section here, all these things that say define need to be undefined, because we don't want to pollute our code with these macros. And that's why the functions are going to have to be in here. Otherwise, this is just not going to work. And then so this is where we're defining them, and then this is the undef section. So define, and then right here is define. Right. So when we highlight this section, we can see it here, and we can see it here, but these sections are paired. They're related to each other, but one is the define section, and the other one is the undef section, and then all the code is going to go in here. Okay, so let's see if that kind of fixes our problem. And then we'll kind of like go and fix some more stuff. Extra tokens at, yeah, blah, blah, blah. So these need to be... we can't keep it like this, right? So we have to... let's just do this. Let's keep kind of like a nice little fancy checksum thing here. But the checksum here is going to be zero-based, because zero-indexed, because these numbers will actually correspond to their actual values in the code. This should go all the way up to 11, if I remember correctly. Okay, so that looks good to me. And then, you know, same thing over here, like these two things. We can also keep the checksums the same. So, this dex sub is 0, and this dex sub is 1, right? I don't know what we want to name them exactly, but let's give it something that helps us know what we're doing, right? Okay, cool. And then over here, this thing here, tau015, well, it's dex tau, and this is dex tau15, so we could write it like that. Okay, cool. So that looks good to me. Let's give this a run and see if we can get this going. And then let's look at our agenda for a second. So agenda, get TAUFRAG working. Let's just get it stubbed in. Let's not get it completely working. Let's just get it, let's just get it, the thing compiling. Okay, so we got a fatal error. So let's go look at that. So I was hoping that this would not happen, but this is the reason why we have this code, so that if we make some transposition errors of some sort, we can find out what's going on. So dex met. So because it happened in this second kind of section here, we know it's the index is not matching up correctly. So this is tau depot dex tau, so we're expecting like 0 and 1, and that's not what we're getting, right? So we're going to printf what we got here, right? So printf lock tau depot %d \n, and then lock tau depot. Holy crap, that's a little bit too much. So we're going to use a macro for that to simplify it a little bit. PF for printf. And do we want to do this locally, or do we just want to like globally define printf, right? I don't know. I'll think about it. And then dex tau ... dex tau dex tau. Okay, so we're going to see what that is. We're going to have some insight into what that is. And then, screw it, let's just put the printf at this scope right here. So define tf printf, and then over here we're going to undef this. Okay. And let's give that a shot. And then once we get this working, we'll put in our agenda that we want to, that some of the functions... Okay, so we got tau depot and TAUFRAG are 15, but the dex tau is this, right? We can fix that right now if we want, right? So we might as well. You know what? We might as well fix that. Here's what we're going to do. It's been a long time coming. So if we go into tau depot data, we have all these variables here ready to go. But they're not actually being used yet, right? So, okay, we're going to change this. At vid IID 0174. And the time is 2:21, and let's just do 23 to keep the conspiracies. We're not going to do this. So, do not do. And the reason why we are changing that from a maybe do to a do not do is because I realize now that that could have disastrous consequences, because now we're coding some of our unit test code to rely on those indexes being completely in order, right? And it would be nice to not accidentally mix these indexes with these indexes or these indexes, right? That'd be awesome to not make that mistake. But to add code to make things more confusing so that we don't accidentally make a mistake like that, I think that's gonna just hurt us in the long run, I think. So we're not going to do that. And we're going to make a reason for that. And then, right now, currently, we're only using this last one, right? We're only using this last one. That's currently all we're using. But we comment them all in, right? So they're all commented out because I didn't want to accidentally use one of the wrong ones. That's the reason why it was like that. Because we're only using this. But if we want to make this kind of checking code work properly, then we can't do that, right? So if we want to do number of tau, we can do number of tau is 16, right? So we can put a 16 in here, right? And then what we can do is we can take this, right? We can go paste this a few times. 1, 2, 3. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So we can paste that all in there. And that's kind of a waste of time, though. So let's not do it like that. First of all, that wouldn't even work because this comma needs to be here. Second of all, this should probably be a 0, 0, 0, if that's what we're going to do here. Let's put an XXX here. And then let's go fork template. Make a little template. Let's throw this in here. Let's find XXX, and we're going to replace it with, guess what, these numbers, right? Bam, easy peasy, right? Unless we don't make enough space before we paste. Okay, so we're going to place it with these. We're going to find the XXX. So let's do that. Let's run farc. And now we've generated all of the code that we need for this, right? Now the reason that I'm going to do this now is because it's just going to make my life easier to stub all of this in correctly than to leave it half-finished like it was, right? It was intentionally left half-finished so that I didn't accidentally use... oh, oops, that's a mistake. Let's paste that back in there. Jesus. Can we go Control-Z? Yeah, there we go. So originally these were all commented out, so I didn't accidentally use them, and they were marked as do not delete because I was eventually going to put them back in. But now, if we want to just finish this code here and not have to like do weird things to make it run as intended, we're just gonna put them all in, right? So we got these. There's 16 of these, right? So 0 to 15. This tau times 16 times 2, right? Because they're in pairs. Okay. So now that we have all this, I think that's all we need to do to get the other code to work. Let's give it a run, and maybe that test will pass now. And so now we've added a little bit of extra checking where it's like, hey, we got this extra benefit of we'll know that they're sequential. Tau depot, tau 00 undeclared, first used in... Oh, so we have to declare the complementary values as well. So in the fragment shader code, right, we have this tau, not this thing, but we also have to address that as well. So let's put a bookmark here. We need to address in the defines, right, we have this tau thing here. Let's just do this. First of all, let's just call this XXX. And now we're going to try to save time, and then we're just going to waste time. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we're going to take these, right, and it's just these numbers all over again, right? So we're going to take these numbers, and we're going to go, hey, bam, in there, right? And then we're going to go, hey, take these numbers, right? So we're going to take these numbers, paste those in there, right? So now you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to 15. So the numbers just match up, right? Nothing fancy. And then we got to find this 15 here. Because wherever that is, we have to... okay, so this is the shorthand. This is the shorthand of this. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we're going to take these, and we're going to paste this down here. Oops, so it looks like we're missing one more. Okay, so now we're going to paste this down here. Okay, and then we're going to paste this down here. I think it went to 15 instead of 16. So we have these shorthand variables, right? So this is a shorthand. These are shorthands, right? And that's all good. I'm fine with that. And we still have more stuff to do, though. So let's go take this right here. Let's take these and highlight them. Because those are going to be the suspects that we need to address. So this right here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay. And then we can take these numbers over here. And we're just going to shove these in here like that. Bam! Okay. And then this little checksum here. We can take this checksum here. We can put it over here. If we like those leading zeros, which I kind of do, we can throw those in there as well. And part of me is like, well, we have 3 zeros here. Why do I only have 2 here? But that's just the pattern we've established over here. So let's keep that consistent. Okay, so now let's give it a run. And then once we have this running, once this is stubbed in, we're going to go do other things on our agenda. Because the thing is if we just start doing one thing and we never stop, we'll just do that whole thing for months. Okay, so we got the system up and running. If we do a P for pattern, we can see our different patterns. We can zoom in to see the different detail at different levels. We can left-click to move around. And now the next thing is not doing any more of this, right? So if we look at our agenda, let's go look at our agenda. So, we're going to go into properties. We're going to, change this to-do around. So we're going to take the to-do. We took the to-do list and we pasted it. I pasted my to-do list for to-dos into here. And we're going to make a new 24. And it's going to be some fragcom functions that use tau depot must be moved into then okay, so now is that correct, or am I lying here? Or is GPU view just looking at the, actually GPU view doesn't. Let me look at GPU view for a second. Let's go open up GPU view. So go look up GPU view.fragment shader. Let's go look at that fragment shader for a second, right? So it does use tau depot's like main memory chunk, but I don't think it uses any tau variables. So if we look in here, we have some mapping function, right? So GPU view mapping function, that's fine. Get the resolution width, get the resolution height. Okay, so actually I changed my mind. In fact, I changed my mind so much here that what we're going to do, we're going to go in GPU view, GPU view, we're going to create an order enforcer guard. So we're going to make an order enforcer guard here for GPU view. And what we're going to do is I've decided that we're looking at the order in which GPU view is. Let's go look at how we enforce order usually, right? So is it called like a I think I just call it a guard file, but really I should just call it ord. Got ya. Got it. Okay, I see what's going on here. So So this error isn't going to work. This is a bad thing. This order enforcer isn't really going to work, is it? This order enforcer that I took it from, because all these things need to be true. Right, so this could be wrong. We'll fix that. So if include, so if we're looking at a GPU view, so GPU view doesn't need to know what pixels mean. So GPU view should be included. Okay, GPU view should be included after fragcom. Alright, so these two constraints. Okay, so if this is the case, the reason is that we don't need to know what this is, and then it's going to come after fragcom, right? So let's put this comment here. Let's put this comment here before TAUFRAG, right? So if this is greater than or equal to 1, it means TAUFRAG has already been included, right? And then this right here. If this is less than or equal to 0, and this is not TAUFRAG, this is going to be fragcom. Okay, fragcommon. Or yeah. So this is fragcom. This is TAUFRAG. Okay. You needs so GPU view needs fragcom's generic mapping functions, but GPU view doesn't need to know what pixels mean, right? And that's the reason. This is the reason why we're not going to include TAUFRAG, because TAUFRAG kind of gives meaning to the different Tau Depot memory pixels. So let's make a note. At vid IID 0174, time is 2:38:11. Order enforcer added. Right, so we added an order enforcer because we see the errors in our way, and we almost decided to refactor the code wrongly. So added this code to catch ourselves if we ever make okay. So yeah, we can put this in here, right? Just have a thing that's going to enforce the order of the libraries in the way that we think they should be. And then we're going to try to get this running again. And then I'm going to look at my to-do list, because that means my to-do list doesn't quite need to be as refactored as I thought it needed to be refactored because of what's going on here. Okay, cool. So if we look at this, we do P for pattern, and we load this in here. We can like zoom in and out. Oh, cool. So if I move between different patterns, right, I'm still at the same kind of position. That's kind of cool. I don't know how useful it is, but that's a okay behavior. I'm okay with that behavior. Okay, so let's go look at our list of things. So fragcom functions that use tau depot must be moved into TAUFRAG. GPU view code should be GPU library should be fine in current position. So change my mind on that. It should be fine in the current position. Okay, this is 25. This is the new. So we're gonna change these numbers, right? So we made a new 24 basically, which is kind of weird the way I'm doing this, but it's just that I want to keep track of that I'm on number 24 and that I've done 24 things so far, and I want to just keep on making this to-do list bigger and bigger, right? I don't know, just that way. That way, as I'm doing this sprint. I don't even know if I started on number 1. I don't know what was originally number 1. Oh, because we're on the... Yeah, I don't know. Fixed toggle tile is actually done. So if fixed toggle tile is done, and pan using right click is done, and polish wheel mouse zoom. Oh god, a whole bunch of this stuff is done. This is done. Polish mouse wheel zoom is done. These are done. So 1, 2, 3. 3 things are done. So we're going to move up everything by 3 now. I'm going to change these numbers. So we're going to get rid of these. So by 3, so we're going to take this. This is going to be 27. It's going to be 28, and this is going to be number 29. P5D AS, I don't even know if that's implemented or not. Let's go look what that is, though. So if we go look in our key binding, so open up keybind, lib keybind, and I'm sure I made the binding offset snap to viewport extent. Okay, that's definitely not implemented. I can kind of see why I did that, because we have the so you can go through the different offsets, and then if we it's probably the G key that's going to do that. No? Oh, Y and then N, and then H is going to snap. Okay, cool. I mean, that's fine. I think that's actually pretty intuitive. But that's not implemented yet. Okay, so we got this new to-do list. So we're going to copy this code. Ooh, not this code. We're going to copy all this code. We're going to go back into our agenda for this. And we're going to edit it, right? So we're going to take everything that we have. Forever to do, use W conversion from now on. Did I lose that when I changed stuff around? No, that's still there. Okay, yeah. So we got this new to-do list. Okay, so fragcom functions that use tau depot must be moved into TAUFRAG. GPU view library should be fine in current position. Compile all variations of libchain to check for backwards refs. Implement P5D AS, and then final PAINT5D shader. Use W conversion from now on. Okay, so that is a pretty good to-do list for what needs to be done. But let's take what we have currently, and let's just ooh, hold on. We have one more thing. So let's go back into here, right? 28 is actually going to be UI rect or something like that. I don't know what it's actually called. It is called UI rects. UIREX get rudimentary UI working for PAINT5D system. So, alright, we're going to create some user interface rectangles and try to create like a basic user interface, but for now we don't have that yet. So, UIREX get, actually, dot D, right, so I might want to make a note that UIREX dot is a dot D dot F file get rudimentary UI. Okay, yeah, so that's good there. I'm satisfied with that kind of list. So now what we're gonna do is we're gonna go into our to-do for today. And yeah, we got number 1 done. Number 1's done, so it needs to be, it's more like stubbed in, but that's good enough. It's stubbed in, it's stubbed in. Okay, so now we're gonna do black market memes. So we're trying to think about what we can do in terms of like getting kind of sales on our Etsy. So we were thinking we could do like collect some memes and then we could like put them in a folder and we could call it black market memes. Now if we're gonna do that, we need to make another stream because I think we'll just put it in our just chatting category and we'll just start collecting memes, right? Or something like that, right? Okay, I'm going to stop streaming, and this was video number... Let's go to the title screen. Video number 174. The day was Thursday. It's now like 12 something, and we did TAUFRAG. We got it stubbed in. We got some more to do. But we're going to stop this and work on some black market memes.